Well, hello again and welcome to the VK6CS Fun with Amateur Radio channel. As you can see, I've removed the high voltage transformer and the high voltage power board, the rectifiers and smoothing board. Happy with that, drawn a line under that, it's all working fine. I've just put those over in the amplifier case. I haven't bolted them in yet, but they're sort of ready to be bolted in. So the next thing I thought I'd look at was the RF in and out switching relays. So what I've done is I have connected them up. There's a coaxial relay. I'm actually holding the camera here because I can't get the tripod in this position. There's a coaxial relay which is going to do the input switching, and there's a vacuum relay there that will do the output switching. And what I've done is I've used the transformer. I've got the transformer connected that I bought the day before yesterday specifically to run those relays. There's a smoothing capacitor and it's standing on a little rectifier bridge there. They are all the actual components that will be fitted in the amplifier. So when I do this test, which is going to be the relay keying delay times, I'll know that what I see here is what I see in the amplifier, because the power supply and the relays are all exactly the items that are going to be fitted. Right, okay, it looks a bit of a bird's nest, just like the other lash up did. But functionally it's going to tell me what I need to know, and so let's get on with it. What I need to know, I didn't tell you what I need to know, did I? What I need to know is what the switching, what the on delay is in milliseconds. Okay, so excuse me while I just fit this thing in here. Right, so I've got a storage scope here, and what this is going to tell me is you can see here it says channel 1 to channel 2, and it's showing a falling edge on both channels. So what it's going to do is it's going to time the delay between the falling edge on channel 1 and the falling edge on channel 2. And the falling edge on channel 1 is the relay keying, the coil being the bottom of the coil, the cold end of the coil if you like, being taken to 0 volts just as it would in the amplifier to be keyed. Between that and the time it takes for the relay contact to make, which is on channel 2. Okay, so and the reason I need to know this is because I need to arrange it so that the output relay comes on before the input relay does, only by a few milliseconds, and that's simply so that the tube has a load connected to it before the drive is connected to it. So it keeps the tube happy, keeps the output relay happy, and it's just the right way to do it. Okay, so first things first, let's so what we're going to be seeing is some numbers here. It'll be in milliseconds, and the first one is going to be the vacuum relay. It's okay, relax, doesn't sound like a vacuum cleaner. Right, so the vacuum relay, let's see what sort of switching delay time we get with that. 2.5 milliseconds, 2.4 milliseconds. It's not always the same. 2.4 milliseconds, 2.4 milliseconds. Now I've said it's never always it's never always the same. It's always going to be the same, isn't it? It's bloody typical. 2.4 milliseconds, 2.4 milliseconds pretty much, 2.2 milliseconds, 2.2 milliseconds, 2.4 milliseconds. Okay, well the worst one I saw there was 2.4 and a bit milliseconds, so we'll call it 2.5. Okay. So now I'll do the same thing with the coaxial relay. Let's write that down, 2.5 milliseconds. Write it down on something. Getting a bit of paper ready would be good, wouldn't it? So let's say that's 2.5 milliseconds. Right, now let's try the other relay. Now the other relay is the coaxial relay that will be used on the input, and I want that to be slower, and if it's not slower I'm going to have to arrange a delay, but that won't be much of a problem. I'll just put another little relay in just to put a bit of a delay in there. I wouldn't expect that to be a problem to achieve, but okay, well let's just see what sort of delay I get with this one. So this is the delay with the coaxial relay. Wait for it. I know you're waiting with bated breath. Sorry about that. Oh, 10.8 milliseconds. You can see that's far more aggressive coil, that one, isn't it? 11 milliseconds. 10.8 milliseconds. 11.2 milliseconds. 10.6 milliseconds. 11 milliseconds. 10.16. Now on this one I'm looking for the best time. 11.6. 10.6. Okay. 12 milliseconds. 11. 11.4. 10.99. 12.2. See what I mean? This one's obliging. They're not always the same. 10.79. 10.6 is the best we've seen, isn't it? 10.4. And 11. Okay, I think 10.6 is the best that I saw there. Now remember, I'm looking for the best time on the coaxial relay and the worst time on the vacuum relay to see whether I need whether or not I need a delay. I'll just scroll something on the board and show you what I'm doing and why I'm doing it. Now, to get the camera back in the right position, it's probably going to be better if I just pause this for a second. So I'll be back in a tick. Okay, let's give that a go. I've got a pen, I've got another pen, so hopefully this one will actually write on the board. You may recall the previous one sort of gave up halfway through the last, I don't know whether presentation is what you call it really, but, okay, let's just focus. Come on, you can do it. Is that going to get it to focus? Yeah, there we go. Right, so the input, this is the RF drive, so the RF drive comes in, goes through the coaxial relay, there's the antenna. I'll show those switches in that position like that. So that's with the amplifier switched out. So you've got the coaxial relay there, and you've got the vacuum, well, I've got the vacuum relay there. Now the amplifier is on the other contacts on those relays. So what I want is for the vacuum relay to make, when the drive radio keying line is activated, when the amplifier is keyed, both of these relays will be keyed at the same time. This one here, because this is 2.5 milliseconds, and this is a 10.6 milliseconds. Excuse me. They're both keyed at the same time, so as soon as the PTT is pressed on the drive radio, 2.5 milliseconds after that, this relay will make. That will put a load on the tube before the drive is applied. So about 8 milliseconds before the drive is applied. You saw this wobble around a little bit, but the best time we saw was 10.6 milliseconds. Worst time we saw there was 2.5 milliseconds. So we know that, you know, the worst time there and the best time there, it's never going to have drive whilst the relay is not providing a load for the amplifier. So this kicks in, gives the amplifier a load, takes any real load off of the relay contacts because there's no actual power present here when it switches over. 8 milliseconds later, the drive is applied and the thing fires up. So that's exactly how I want it to work. So I don't need to arrange any other relay in here for delays or anything else. I don't need to put any components in there because these relays switch at different times, even though they're switched together, but the delay of the actual devices is different, and it's actually spot on. It couldn't really be much better than that. So all I have to do is connect those two relays to my little activation relay. The only reason the activation relay is in there is for the so that the drive radio only has to key 30 milliamps and not, you know, an amp or two or whatever, or half an amp. And the test configuration that I just used, that was plus 12 volts. I'll only draw one relay because the circuit was the same for both of them. And that had the relay coil like that, coming down here to a switch. It goes to ground, and then I had a resistor coming down there. The relay contact to ground, and I had channel 1 of the scope. Channel 1 of the scope connected there, and I had channel 2 of the scope connected there. And what was happening is when I key this, that voltage there drops to 0. That causes that contact to pull in, and that voltage there to drop to 0. I've still got a cold, sorry about this. And what the storage scope does is it measures the time between the two. So it sees this drop to 0, and then it times until it sees this drop to 0, and then it displays the time. So very, very simple test setup. Used exactly the same test setup for both relays. Used all of the components that I'll actually be using in the amplifier, so I know these are the times that I'm going to get in the amplifier when it's built. Even down to the power supply transformer, the smoothing capacitor, and the rectifier bridge. So that's looking very good indeed. I think I can just go ahead and actually put the relays in the sort of in and out module. So I'm making this amplifier modular. So there'll be a module that does the in and out switching that will just bolt into the box somewhere, and that will have both of those relays in it. Might actually be 2 boxes. I haven't quite decided yet, depending on how likely I think it is that it will get any feedback problems, but I don't think it will, because it's a grounded grid amplifier. The output's 180 degrees out of phase with the input, so it's not really likely to set it off. Anyway, I'm starting to go off at a tangent. Think out loud. Not thinking at all is, I suppose, something unusual. All right. Well, I hope you found that interesting, and I'm sure you're relieved not to see the high voltage power supply. Almost as relieved as I am. So thanks for watching. I'll catch you next time.